let me introduce then to the people who are here, and I'm sure more will join us. We have today two alums. We have Margaret Sturgill, who got her PhD here in the 1990s or so. And we have Asher, my son, who got a bachelor's degree recently, 9 years ago. So first, they'll both be telling about their experiences as students and after being students. And as I pointed out before, both Margaret and Asher are similar in several ways. They're children of faculty members here, and their father speaks to them in a language other than English. So Margaret, it's good to have you back in Kentucky, and it's your turn to go ahead.
Thank you very much. So hopefully you'll be able to see my screen and my slides. Can you see speaker view or can you see my slides?
We can see your slides.
Okay, great. So by the way, I did not get my PhD at UK. I got my undergraduate in computer science and math. And then I continued on for a PhD actually at University of Utah. But that's been, you know, I just realized when I started to think about it, I realized that I graduated from UK 31 years ago. It's been a long time. But this is my professional life. And it actually started before graduating from UK. Actually started my freshman year. I knew I wanted to do computers, and I went to Professor Kubota and asked him for a job. He ran the departmental computing facilities, and I said, okay, I like a job. And he went, okay. Here, handed me a copy of Carnegie and Ritchie, said, learn C and write me a system for doing help support, and it was a server client system. And one thing he forgot to tell me is that this is hard. And I would like to tell you that it is the best thing not to tell your students. Most of the time, they will figure it out if they don't think it's hard. It took me a couple of months. I had to learn Unix networking. I had to learn curses because we had no graphical interfaces yet. I had to learn C, and I got the job. And, you know, so several of the faculty members remember me running around answering their questions and doing backups. You know, we moved then to Utah for me to do my PhD in computer science, and there were only a few options. Really, there was hardware, which was not gonna happen because I don't do hardware. There was operating systems, and there was computer graphics, and never had computer graphics. I looked at it and went, okay, why not? And actually, my PhD is in user interfaces for computer-aided design for mechanical part design, where you go from a sketch to a actual finished part on a CNC machine, because I was a part of the Alpha 1 program. And I never did anything like that again. The area was great, but I felt like, been there, done that, I want to do something different. And I joined HP in Greeley, Colorado, because we moved again. And this time I joined the part of the company that made scanners. I had to completely learn completely new stuff. But my first project was, they said, well, we need somebody to write Windows 95 device drivers for the scanner. And I went, okay, I knew assembly. The fact that it was Motorola assembly and not Intel assembly, it occurred to me that maybe it's a problem. And nobody told me this was hard. So I wrote device drivers, and that's got shipped. And I became a maintainer of the main library for the scanner programming language, which was the language that you could talk to the scanner through a serial port. And because I was this worldwide maintainer of this, I was working with the team that wrote, that built a new scanner that was the Sturgill Jet 6S, which was very interesting because it had a dual scan path, so you actually did a normal scan at the same time as the previous scan. And we patented that, and that was my first patent that I have ever gotten. And but in the meantime, Brian and I, hopefully some of you guys still remember Brian, because he was one of the other system administrators. We had a daughter, and it was a good time to leave HP. It was during the dot-com boom, and Brian's company needed somebody to actually run all the day-to-day issues. And so I thought, okay, something new, I'll try it. Nobody told me it was hard, again. So that's what I did. Had to learn a lot on my own. I would suggest if there's any students on this, watching this, take an accounting class. It's actually very useful in the future. If you're gonna have your own company or work for somebody else, understanding financials is very useful. And then, of course, there was the dot-com boom. After the boom, there was the bust. The bubble broke. The company shrunk. It never went away, but it did shrunk. And so it was time to get back to programming. I sort of missed it anyway. And I had an opportunity to come back to HP actually as a contractor this time. So very different, but working for HP Labs. And the project that I actually worked on was actually hold on, next slide, was something called book prep. And if you remember Google book projects where they scanned every book they could get their hands on, the Open Content Alliance was sort of a reply to this that took into consideration people's copyrights. At the same time, HP Labs working on a project called Book Prep, which would take books and scan them, clean them up really well, and make them ready to be printed again. So books that were out of print could be again printed on demand, which was a great idea. But we realized since we were already generating PDFs so they could be printed, we could actually extend this project and prepare the books for actually to be displayed online. And the problem we ran into is that we wanted these books to be searchable. And so my job ended up being is how to create a searchable PDF that looks like the book, but does not, looks like the book, but you can search in it and actually find strings. So normally when you have a searchable PDF, you actually lay out the actual text, and you can grab pieces of text and search in it. But in this case, we had images of books. And so what do we do? And what I came up with is an idea where you create an invisible text layer where you actually put the words in. When you run an OCR on a page, you get locations where these words are. So we created a hidden OCR layer and text layer where the words were in the proper place on the page, but you cannot see it. And then we overlaid it with a picture of the actual page. So when you actually searched on the page, the little rectangle that showed you where the the word is actually was displayed on the top of the image. And so people were searching in the images of the book. And it was really cool. And then the money ran out. And I was done with this project. And soon after that, I had an opportunity to come back, at this time to come to labs as a visiting scholar. You can sort of think of it as similar to a postdoc position. And this time, I was brought in to work on an interesting research project called, and this is probably my favorite project I have ever worked on, was the image-based forensic service. And the idea behind this was could we detect counterfeits of packages? So if you imagine, a company like HP sells ink cartridges, and they are in packages, and people love to actually counterfeit HP ink. In general, counterfeiting is a business. Most counterfeit operations really can be thought of a business with a very big R&D operation. They just don't spend any money on marketing. They use the companies whose products they are counterfeiting as their marketing operations. So every company whose products are being counterfeited is a moving target. And the counterfeiters, because they spend a lot on R&D, get better and better at it. And so tools for detecting counterfeits have to get better and better. And we had this idea that we could detect counterfeits by looking at the printed data on a package. If you look at a cartridge package, there's normally some image. And these images tend to be, for companies like HP, are printed on very high quality printers. They are very high quality uniformity. And so we thought that maybe we can just detect, scan, have people take a picture or scan the image of the package, and we'll be able to tell them, if this is real or counterfeit. Great. And we actually came up with a system to do this, and we presented this at the IEEE WIFS conference. And I will tell you what we did in a moment, but we went to corporate security and said, listen, we came up with this great idea and we are gonna do this. And they went, okay, but we can already tell what's counterfeit. We have our own things, that can be looked on the package, and we know what to look for, and we can tell where a package is counterfeit. So it's great that you can do this, but it's not that useful. But they said, what you could help us is to figure out who to go after. Is there something, which are important counterfeits and which are not? And we went back and said, well, maybe this can be actually used for something like this. And it turned out that it can. So the idea behind finding the counterfeits was that we would take an image on a package, divided actually into 12 maps, and that there will be color maps, and some besides, like, the standard red, blue, green, we could look at saturation and whatever other maps we wanted to. And then on each one of these maps, we generated a set of metrics. We then used a modify k-means to actually cluster these, to see if original classification was we would start we would first run a classification of real versus counterfeit, and all we were, able to do is that we could tell which images were real and which ones were counterfeit. But that wasn't that useful. So we wanted to see if we could actually divide the counterfeits or the images that were not in our initial set into more subsets that would actually somehow these samples were related. And turns out that it was quite possible. We came up with a secondary metric that was based on correlations within a map versus within the whole set. So we would calculate a mean correlation value for the same metric on all the maps versus a metric with correlated with all the other metrics on the same map. This value, which we call MWFD, was the distance that we would look at, that we would actually use to distinguish the classes. But if you look at this, if you realize, because we are using a single metric, all the samples in SA1 and SA2 actually lay, you can think of it as laying on a circle around the referent aggregate, and so they would be clustered together because we are using a single metric. So we then broke up the big aggregate we created by, again, recalculating the set of metrics that would define it, and look at outliers that where its MWFD was not consistent within its group. So any item that had a larger outlier was thrown out, and we were able to subdivide the large S1 aggregate into smaller pieces, which looked like these samples were related to each other somehow. Well, what we started to notice is that samples, slides are not advancing because I haven't really moved, because the next slides will be a different project. So, sorry, I was answering a question in the chat. When we realized that we could actually, we were seeing groups within the counterfeits, and the samples were coming from different places, we realized that we could actually look at the counterfeit networks that seem to be out there. We could see where the samples came from and actually tell which samples came from large producers, because let's say the same counterfeits that clumped together moved, actually seem to show up all around the world. And this was a very interesting realization that we then passed on to the security people. So after, I should have put some slides in between. After I worked on the image-based forensics, I then moved to I actually got a permanent position within HP Labs, and switched again to a completely different areas. This time I worked on security marks, on not necessarily security marks, but in general in barcodes. And the project that I worked on was actually using what's called incremental information objects. And these, like progressive barcodes, allow you to carry more information than a standard black and white barcode, often by adding color. And because they are, the incremental part of this is that we actually encode in the color part of the barcode, not the actual value, but the transition. So the situation, what you're seeing is that you have a barcode. In this case, we only have color information. And because we are a printing company, we are actually adding colors. So a white can go move to only 3 possible colors by printing with cyan, magenta, or yellow. If you overwrite, for example, magenta with the cyan, you will get a blue, and so on. And so you can encode actually this, these transitions, and instead of having specific value, it's the transition that describes the string. And normally the progression is 1-to-1. And what I was actually looking at is actually, well, what maybe if we could do many to one, the transition has to actually occur opposite. So you have to pre-calculate this data. But the idea is that now the transition is specific in that you actually are allowing the transition strength to bring you 2 separate barcodes bring to the same one. And that allows you for a item container relationship. And if you set the transaction, this transition to actually allowing specific number of set bits in it, then you actually can encode workflows in it, because you can know which step in the workflow you are in based on the number of bits that were set in the transition. And so this is an example. Actually, what happens is where you can have a container which contains palettes in it, and you can transition from the palette data back to the container. The palettes can contain other boxes, which also their barcodes can be transitioned into the barcode that's on the palette, and so on. By knowing also how many bits were in the transition, you can actually set some security permissions based on where you don't have to go back to the original database, but just by looking what the transition string is and how many bits were set, you can set some flags that will indicate that there is a possible problem because somebody should not have scanned a specific item, for example, because the number of bits in the transition does not indicate that they are not supposed to do that. And then it was time to move to something else. And I was given an opportunity to move to a completely different group in labs, and they needed somebody to write device drivers again. And I said, well, why not? I'm done with the security printing. Let's move to something else. And then I got a chance to move into predict. Somebody needed help with data engineering. I didn't know much about it, but I could learn. So I switched again. And we are almost near time, so I will sort of run over this really short. But by the time I got to this point, I ended up with 32 patents. In the industry, at least, patents can be very important. They not only protect your current products, but they often give you what's called the right to operate. And that is that even if you might be using somebody else's patent, you can usually exchange the patents between each other so that everybody can work together, so you can operate within an area and actually create products. And So even though I have a PhD, I never published much. But within the industry, you can do other things. And in my case, it was being involved in patent creation. So that was good enough for labs. So even if you are not big into specific research, you can do other things in corporate labs that may not be necessarily available to you when you are hired for a specific work. You can switch and you can learn new things. So in general, I have actually moved now into architecture. I am a chief architect, software architect for the group, for a machine learning group that I'm in. I personally don't do machine learning, but I architect everything that goes around it and the deployment, which is very different from where I started. And pretty much most of the things I ever worked on, I worked on the job. But when we go back to the beginning and when I finished UK, I had what was called a numerical option in CS. And so most of the upper division classes I ever took were either math or math related. And they taught me how to think and how to learn. And it was perfectly okay to switch and learn something new. And as long as you're willing to learn throughout your career, you'll be okay. You can always find something new to do. Let's see, we have 4 minutes left. So if anybody has questions, I'll be happy to answer. Okay. So let me, since we have about 3 minutes, I'll tell you a little bit about what I'm working on right now. And it is, so I said I'm working on a machine learning team. I am actually working with chatbots. And this is a new thing that we started doing. I actually work with chatbots for customer support. And this is, again, something I have never seen. How hard can it be? Okay, well, it is, because chatbots do not support turn-by-turn navigation. They are very good at going and fetching the information you asked for, but not doing the doing turn-by-turn stuff. So that's what I'm currently working on. I am architecting a system where it will allow us to easily do turn-by-turn navigation of a chatbot. So it's very different, has nothing to do with computer graphics. It has nothing to do with scanners. It has nothing to do with security printing, but that's okay. We just need to continue learning for the rest of our time. So I think I am done, and I think I'll be passing on to Asher, unless there's any questions. Yes, yeah, please.
Several times in the middle of a project or near the end, the funding disappeared. What is it like to work for a company that decides what it is you should work on and can just pull the plug at any time saying, well, we're not interested anymore, or we have no more money?
You just adjust. I mean, so it helps to be open-minded about things. I'll tell you what happened to me recently. If you notice at the end, it says that I'm in the transformation office. My lab got closed. Literally, one of the labs that I worked in, the AI and emerging compute lab, and the company decided that this lab was not working for them. They unfortunately let go of about half of the lab, and then they moved the rest of the people within the lab, and I ended up outside of HP Labs. All of a sudden, I was told, you are now in the transformation office. And it's not a pleasant feeling, but you adjust. I was lucky enough that I could continue working on the project I was on. But if it was not the case, I would just move to something else. But if you notice, because I worked on a variety of things, you just move to the next, I can easily adapt. Some people can't, and then it's hard.
All right, well, I guess one has to learn how to adapt
Yes.
then. It's one thing that computer people are pretty good at, because debugging a program often means adapting to whatever it is the computer is telling you and trying to figure things out. So we get used to dealing with frustrations of all sorts. Well, thank you very much, Margaret. I'm sure if people have other questions, they can ask you during chat.